Welcome to a series of short but powerful videos for demystifying situational problems, brought to you by MaST and Dean. In this short video, we will talk about anxiety, math anxiety. In some cases, anxiety can serve to motivate and enhance performance, but it often negatively impacts students and teachers alike. So what does the latest research on math anxiety say? Why do situational problems often cause stress, and what can you do about it? Curious? Then let's get started. For many, situational problems are an exercise in emotional response. The situational problem document is placed before the student and they're expected to go for it, while teachers cross their fingers in the hope that they're successful. Not surprising that they cause stress. But other than the fact that situational problems are much more than simple pen and paper activities or evaluations, why do they cause so much stress? There are four premises from which the four dominant theories emerge. The disruption theory sees math anxiety as a precursor to poor math performances. The reduced competency theory proposes that the child's poor math abilities trigger the feelings of anxiety, leading to poor performances. A third, the interpretation theory, considers how a child interprets their experience with mathematics as the trigger to math anxiety. Finally, the last proposed theory, the reciprocal theory, considers the intricate and back and forth relationship between the disruption and the reduced competency theories. It is important for us to distinguish them, as they each require a different response to correct. Picture this. A student is given a traditional situational problem, and before he even opens it and sees the question, tears start trickling down his cheeks. What's happening here? His working memory is overwhelmed. He tries to simultaneously deal with his negative thoughts and fears about math and the math problem itself. Oddly enough, students with strong working memories may be at a greater long-term disadvantage than others, as that ability makes them rely heavily on strategies that require strong working memories, instead of developing problem-solving strategies. Eventually, because of the greater and greater volume of information needed to be handled, anxiety develops. These students have not developed adequate problem-solving skills, and they are now at a greater disadvantage. There are many approaches available to decrease or to avoid triggering anxiety, like relaxation techniques, for example, learning how to meditate, doing physical activity like yoga, or having students write down their concerns before attempting the task. Sleep has also proven to be extremely efficient in decreasing long-term anxiety levels, so encourage your students to get to bed early. However, all of these require time and practice to be efficient. So most of all, be patient when you practice them. Teachers are generally more comfortable in providing solutions when poor math performance originates from the reduced competency theory, as it stems from what they do. Teach. In this situation, the mathematical knowledge required to solve the problem is simply unknown or not mastered by the child. This includes elements of mathematical reasoning, like understanding concepts and procedures, but also the approach needed to solve the situational problems. In this scenario, teachers look for instructional responses that address understanding the content. But the difficulties also come from a lack of knowledge in how to solve the problem. That is, understanding the question asked, extracting relevant information, how to structure the responses, among others. More ways to address this trigger could be found through culturally responsive curricula, as in indigenizing the curriculum to increase engagement, and through response to interventions by providing small group instruction or targeted support. You may have heard students say, "I'm just not good in math," or even parents say, "Well, I wasn't good in math when I was in school." This is where the interpretation theory comes into play. It considers the impact of the interpretation of the child's reaction to math anxiety as the driving force between the anxiety experienced and the mathematical performance of the child. Math anxiety is not only the result of avoiding doing math or not being good at math, it comes from the interpretation one makes of their abilities. This interpretation theory comes as much from what goes on in our heads as what we hear around us. But what can we do about this? One thing you've already heard about, I'm sure, is developing a growth mindset. It's important to know that our internal narrative could be positively affected by a growth mindset. We must also know that we, as teachers, also influence children in their perception of their own abilities. Other early triggers of math anxiety stem from home or lingering stereotypes, like girls are not good at math. Research supports the knowledge that everyone can be good at math. We must believe that to be true and work on the premise that our students are just not there yet. An emerging theory is based on the bidirectional relationship between the disruption theory and the reduced math competency theory. It is called the reciprocal theory. This theory appears to parallel the interpretation theory. For example, imagine a child who's been successful in mathematics and, for whatever reason, underperforms on a test or assessed activity. Suddenly, he or she may become more anxious when challenged by a similar problem. This could then lead to the student shying away from further challenging mathematics, resulting in more unsuccessful performances as he fails to increase his bank of knowledge and begins to fall behind. Throughout this process, students may become their own worst critics as their interpretation of the events focuses on their failures rather than their successes, becoming a self-fulfilling prophecy. These premises make it clear that understanding how math anxiety develops becomes extremely important. To know each is to know how to address our students' individual needs. We know situational problems cause stress. By looking at what lies beneath, we can navigate the numerous avenues that exist to lower math anxiety in our students. As you've heard, the most fundamental notions that we must adhere to stem from research and tell us that math anxiety is real and has identified sources, but it can also be addressed, prevented, and in many ways resolved. It is time for us as educators to take on the responsibility and become leaders in addressing our students and our own math anxieties. There is no better place in our current reality to take on this challenge than through reinventing our approach to situational problems and truly developing that elusive competency. This video looked at math anxiety. If you need some additional support with situational problems, please reach out to your math consultants and check out the other videos in our series for more information about situational problems.